All last class we have completed the inverse trigonometry introduction part 1, that is we have drawn the graph of all 6 trigonometry ratios and then we have found the domain and range. These things we have discussed in the last class. This class we are going to discuss what is the definition of inverse trigonometry function, how we are defining the inverse trigonometry function, then we will see principal branch values of the 6 inverse trigonometric ratios. So what is first we have to recall the definition of a function from the chapter 1, that is f is the function from x to y. So x is my domain, y is my codomain. We are defining a function f from x to y. If the function is 1 1 and onto, that is the function is bijective. 1 1 and onto, no problem, onto 1 1. Okay, the function is 1 1 and onto me, it is bijective. If it is bijective means I can define a function, another function g from y to x, g from codomain to domain, I can define a function. So that function is called inverse of the original function. So g equal to f inverse. So similarly we are going to define a function here. We know that f of x equal to sin x. This function is, usually we will write the domain as real numbers, codomain is minus 1 to 1. So f is a function from real numbers to minus 1 to plus 1. So the sin x is not 1 1 in the real number system, in the domain real numbers. Y means it is 1 1 and onto in some particular interval. So I am going to define that interval alone. For example, I am going to define I will take minus pi by 2 to plus pi by 2. Instead of this, I can take minus 3 pi by 2 to minus pi by 2, or pi by 2 to 3 pi by 2, or 3 pi by 2 to 5 pi by 2. Like that, I can take any interval. So for our convenience, I am taking minus pi by 2 to plus pi by 2. Now I am defining a function, means that is from minus pi by 2 to plus pi by 2 to minus 1 to 1, means this will be 1 1 and onto. Clear? So now I can write f is a function from minus pi by 2 to plus pi by 2 to the closed interval minus 1 to 1. So this is 1 1 and onto. So I can define the function from y to x, that is define a function from minus 1 to 1 to the closed interval minus pi by 2 to plus pi by 2, which is nothing but the sine inverse of x. It is nothing but sine inverse of x. I have taken x here, so we can take it as sine inverse of y, because if I am taking sine x equal to y means my function will be x equal to sine inverse of y. Clear? So similarly I can define all 6 trigonometry ratios: cos inverse of x, tan inverse of x, and cot inverse of x, secant inverse of x, cosecant inverse of x. Like that I can frame all 6 inverse trigonometric ratios. Clear? So generally I can write here sine inverse is a function from closed interval minus 1 to 1 to closed interval minus pi by 2 to plus pi by 2. So similarly I can write all 6 trigonometric ratios. So how I am going to define means, for example, I am going to take the cos inverse function. Cos inverse functions also minus 1 to 1 to the closed interval 0 to pi. Similarly I can define the cosecant inverse function, that is from real numbers except open interval minus 1 to 1 to the closed interval minus pi by 2 to plus pi by 2 except 0, because the cosecant function is not defined at x equal to 0. So I am taking that, excluding the point in the codomain, that is in the range set. Similarly I can write the secant inverse function. Secant inverse function is real number minus 1 to 1, real number except minus 1 to 1 to, I can define closed interval 0 to pi by 2 except the point pi by 2, as well as here also the cos function is not defined pi by 2, secant function is not defined at pi by 2, so I am excluding that point pi by 2. Next I am taking tan inverse function. This function is defined from real numbers to open interval minus pi by 2 to plus pi by 2. Similarly, cot inverse function is defined from real numbers to open interval 0 to pi. So like that I am defining this 6 inverse trigonometry ratios. This branches, this values minus pi by 2 to plus pi by 2, 0 to pi, minus pi by 2 to plus pi by 2 except 0, closed interval 0 to pi except pi by 2, open interval minus pi by 2 to plus pi by 2, open interval 0 to pi. These are called principal value branches of corresponding inverse trigonometric ratios. So the sine inverse trigonometric ratios corresponding principal value branch is this one. Similarly for cos inverse, similarly for cosecant inverse, secant inverse, tan inverse, cot inverse. These principal value branches are very important point that we are going to use in the following problems. Now we will see one graph example, only one example for the inverse trigonometry functions graphs. So this is the example for the inverse trigonometry graph, sine inverse for sine inverse. So I am drawing the graph here. So this is my x-axis, this is my y-axis. So this is 0, it is pi by 2, it is pi. Similarly it is 3 pi by 2, down minus pi, this is minus pi by 2, minus 3 pi by 2 as well as. This is the graph for sine inverse. So y equal to sine inverse of x is the graph of the sine inverse. Here in your textbook it will be given as this portion alone darken here, this portion alone darken. So this is our principal branch value. This is our principal value branch. So it is darkened. Similarly for cos inverse, tan inverse, cot inverse, secant inverse, cosecant inverse, everything it is given as darkened portion. That portion is our principal value branch. Now if you are drawing the sine functions graph, if you are trying to draw the sine functions graph, mean that will be like that. For similarly this side also will go like that. So this look like if you are keeping a mirror here, what is the line? This line is equal to y equal to x, means if you are keeping the mirror, means it will the other image will be the mirror reflection of that. Both will be mirror reflection about y equal to x. Clear? This is the y equal to sine inverse graph and y equal to sine x. I have drawn the sine x curve and sine inverse curves in the both diagram. It would like that. It is rough diagram. Exact diagram it is available in your textbook. Okay, now we will go to the exercise problems. Exercise problem, exercise 2.1. So first question. So we have to find the principal values of the function. So what is the given function? Sine inverse of minus 1 by 2. For this we are going to find the principal value. So what we are taking means let y equal to sine inverse of minus 1 by 2. So what is the value of sine y now? Sine y equal to minus 1 by 2. So don't consider the negative symbol or positive symbol, just write the value of 1 by 2 for sine. So sine when will take 1 by 2? It is clear that from the table we can easily say that sine pi by 3, that is pi by 6, that is 30 degree is 1 by 2. So we are writing pi by 6. So now we have to write that the minus symbol we have to eliminate, that is we have to write that we have to bring the minus sign to inside, or we have to use the quadrant. So now when sign will take negative, first quadrant positive, second quadrant positive, third quadrant negative, and fourth quadrant negative. So now I can mention the third quadrant as pi plus theta. Second quadrant I need to mention as pi minus theta. First quadrant I need to mention as theta. Fourth quadrant I need to mention as minus theta. These are the major things we need to keep in our mind. Clear? So it is available negative. So this can be written as sine of pi plus pi by 6, that is sine 180 plus theta minus sin theta, or one more thing available, I can write that sine of minus pi by 6. So simplify this, what we will get, sine of 7 pi by 6 will come, taking LCM means, or I can get sine of minus pi by 6 will come. So what is our principal value of sine inverse? Principal branch of sine inverse equal to, which means that is this 7 pi by 6 never belongs to the give interval. This minus pi by 6 only belongs to the interval. Clear? So principal value branch of sine inverse is minus pi by 2 to plus pi by 2. So that particular value must be lies in the interval. Clearly we can say that minus pi by 6 belongs to the closed interval minus pi by 2 to plus pi by 2, that is minus 90 to plus 90. This minus 30 is available in the interval. So I can write y equal to minus pi by 6. Clear? One more problem we will see. See now the question 2. Question 2 is given that cos inverse of root 3 by 2. So I am taking that cos inverse of root 3 by 2 equal to y. So let y equal to cos inverse of root 3 by 2. Very easy problem. See that. Suppose now what is the value of cos y? Cos y equal to root 3 by 2. So when cos will take root 3 by 2 in the table, trigonometry table, cos root 3 by 2 will take it as 30 degree. So we can take it as cos of pi by 6. Clear? Cos root 3 by 2 means sin 1 by 2. Sin 1 by 2 means 30 degree, that is pi by 6. So like that we can keep in your mind. So cos pi by 6 will come. Now check that this pi by 6 belong to the interval or not. What is the principal branch of cos inverse? That is 0 to pi. So clearly pi by 6 is lying inside the interval. So directly I can write y equal to pi by 6, because pi by 6 belongs to the interval 0 to pi. Suppose this pi by 6 does not belong to the interval, means we have to check whether wherever cos is positive, like that we have to check. For example, cos is positive on first quadrant, all silver teacups, and positive on fourth quadrant. So if you are writing this function, this we can write it as cos of minus pi by 6 also equal to root 3 by 2, but this minus pi by 6 does not belong to the interval. So that's why we are excluding that. Usually it is positive means directly we can take, because first quadrant values for all sine inverse, all trigonometry, inverse trigonometry functions will satisfy. Clear? So one more question number 3 in the same model of this one. So that is cosecant inverse of 2. So let y equal to cosecant inverse of 2. So what is the value of cosecant y? Cosecant y equal to 2 will come. So when cosecant x or cosecant function will take 2, that is cosecant function means 1 by sine function. So sine function when will take 1 by 2, that same case cosecant also will take 2. So similarly it's clearly that pi by 6 it will take 2, that is 30 degree. So I can write here cosecant of pi by 6. Now what is the principal branch of cosecant? It is nothing but minus pi by 2 to plus pi by 2 except the point 0. This is the principal value. Clear? Range of principal value. So now I can write directly y equal to pi by 6, because pi by 6 belongs to the interval minus pi by 2 to plus pi by 2 except to 0. Clear? Next question. Question number 4. So totally 9-10 questions are there. Question number 4 now. What is given? We are going to find the principal values of tan inverse of minus root 3. Principal value of tan inverse of minus root 3. As well as similarly we have to take y equal to tan inverse of minus root 3 here. So what is the tan y value? Tan y equal to minus root 3. Tan y equal to minus root 3. So we have to leave the symbol and check only when tan will take root 3. Tan will take root 3 at 60 degree. Clear? So 60 degree means what is that in radian? Pi by 3. So I can write that minus of tan pi by 3. Clear? Minus of tan pi by 3. Now we have to check that the symbol when tan will take negative, tan will take negative 1. Here it is positive all, here it is negative, here it is positive, here it is negative. So first, second quadrant and fourth quadrant it is negative. So how to mention second quadrant? As I said already, second quadrant means pi minus theta. So we have to write this as tan pi minus pi by 3. One more value, tan when is that negative. So minus theta, that is tan of minus pi by 3. See that tan minus theta equal to minus tan theta, tan of 180 minus theta equal to minus tan theta. Clear? So now among this, simplify this first. So tan of pi minus pi by 3 means 2 pi by 3, or this will be tan of minus pi by 3. Now what is the principal value of tan inverse? Principal value of tan inverse lying on the open interval minus pi by 2 to plus pi by 2. So clearly this is equal to 2 times pi by 3, that is 2 times 60 degree, 120 degree. 120 degree is clearly beyond the interval. So only this minus pi by 3, minus pi by 3 means minus 60 is lying in the interval. So we can write that y equal to minus pi by 3, because minus pi by 3 belongs to the open interval minus pi by 2 to plus pi by 2. Clear? One more problem we will see, problem number 5. So what is problem number 5 given? So we have to find the principal value of cos inverse of minus 1 by 2. So as well as let y equal to cos inverse of minus 1 by 2. Now what is the value of cos y? Cos y equal to minus 1 by 2. As earlier we have done, negative we have to, negative symbol we have to leave, only consider the 1 by 2. When cos will take 1 by 2, cos is taking 1 by 2 means sin will take root 3 by 2, that is 60 degree. So we have tried pi by 3. So cos of pi by 3 as cos 60 degree, cos 60 degree, it will take 1 by 2. Clear? So now when cos will take negative, first quadrant positive, all silver teacup. So fourth quadrant positive, second and third quadrant is, it is negative. So second quadrant will be mentioned as pi minus theta, third quadrant will be written as pi plus theta. So we can write both possibilities. So sin of pi minus pi by 3, or sorry, cos of pi minus pi by 3, or cos of pi plus pi by 3. Simplifying means what will come? Pi minus pi by 3 is cos 2 pi by 3. Here you are simplifying means pi plus pi by 3 means 4 pi by 3. That is 180 plus theta minus cos theta. Cos 180 minus theta minus cos theta. So among all these two, what is the principal branch of cos inverse? Principal branch of cos inverse is closed interval 0 to pi. So closed interval 0 to pi means 0 to 180 degree. This angle is 120 degree. 2 into 60, 120 degree. This angle is 4 into 60, that is 240 degree. So clearly this is lying in the principal value branch. So I can take this as my answer. So y equal to 2 pi by 3 is the principal value of the given function, because this angle 2 pi by 3 belongs to the closed interval 0 to pi. Clear? Okay students, remaining questions 6 to 11 remaining questions we will see in next class. From 6th question onwards we will see in next class. Most probably next class I will complete this chapter. After that we will move to derivatives chapter. Thank you all.